right, it's time to kind of put together everything that we've learned. Um, we're going to find all of the roots of these polynomials, even these upper degree guys. We're going to try to find every single root. Now, if this is third power, we know we're looking for 3 roots. If it was fourth power, we'd be looking for 4 roots. I think on your assignment, the worst it gives you is 3. But before we do that, there's one more trick they want me to show you, and that's finding the upper and lower bounds of these polynomials so we don't have to look everywhere for the root. Again, this is not one of my favorite tricks because, it's kind of outdated. This is really for if we're doing this by hand. It's a neat little trick, but it's just not that useful. The idea behind it is they want to give you kind of a range in which you need to look. So if we could figure out, oh, well, I know for a fact that all of my solutions are going to be between -3 and 7, then this is now the only place that I'm going to have to look. And using our rational zero theorem, we can look for rational numbers between there. Okay, so it's asking us to use this. Let's figure out how this trick works. So, for example, let's try out on the positive side, let's try out 10 to see if 10 is an upper bound. So what I'm going to do is I'm going to do synthetic division on this root. Okay, get my calculator ready because I'm going to need it. So 1, 10, -5, -50, 24, 240. I said I was going to need my calculator. All right. Now, after doing this division, first of all, notice that 10 is not a root. But what this theorem that we're going to use says is we know it's an upper bound in the positives if all of these numbers are non-negative. In other words, they're either positive or they're 0. So in this case, I know that this is not an upper bound in my positives because of this number right here. I could have actually stopped right there. Okay, so I need to go higher if I want to find an upper bound. So if you look, I know this guy needs to be at least 15 for this guy to be positive. So I don't know, let's try 20. Okay, so 20, 5, 100, 174. Now I am going to need my calculator, but I'm pretty sure we're going to be fine here. 3,480 minus 120 is, and if you look, these are all positives, so this is an upper bound. But what it wants you to do on your homework, it wants you to find the smallest upper bound that you can. Because I could say, oh, well, 1 million is an upper bound, but I want to find the lowest one. So I'm narrowing it down as much as possible. Well, a minute ago, we figured out that 15 would at least get us past this first round. So let's try 15. 0, 74. This is some big guy. This is going to be positive. It's my stray marks there. So this is all positive. Okay, or non-negative, I should say, because 0 is fine. Okay. So I could test out 14, but I know 14 is going to fail right here because I'm going to get a negative. So 15 of all of my upper bounds, my integer upper bounds, this is the biggest one. So all of my roots are going to be 15 or lower. Okay. Well, now let's check the negative end. Sorry, I didn't show you that. 15 or lower. Now let's check the negative end. Now, it's going to be a little goofy for us to check the negative end. I'll explain why in a second. But let me just show you how you would do it, and then I'm going to tell you why we don't need to on this particular problem. So, I don't know. Let's try negative 10. Now, the test that we're going to do on here is slightly different. Remember on Descartes' rule, on the positive end, if we had all positives, then that meant no sign changes. Well, on the negative end, there's no sign changes, there's no roots if it's switching signs each time. So if it's switching signs each time, I'm going to go ahead and say that that is a lower bound on the negative end. So let's try this. Get negative 25, 250, 324, negative 3,240, negative 3,360. Positive, negative, positive, negative. This is a lower bound. Now again, I'm not searching for a lower bound. I want the biggest lower bound so we can squeeze this guy as close as possible and really figure out where our roots are. Here's the thing. I know from Descartes' rule, okay, I've got 1, 2, 3 sign changes. So on the positive end, there's 3 or 1 roots. But if I'm looking on the negative end, okay, I changed these 2 signs. Negative, 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 negative. There are no sign changes. So there's not going to be any negative roots. So I can go all the way to negative 1. And it should still give me alternating signs. Let's try it. So negative 1 is negative 16, positive 16, 90, 90, negative 30. So positive, negative, positive, negative. So even at negative 1, this is a lower bound. So all of my solutions are going to be between negative 1 on the negative end and 15 on the positive end. So I don't have to try everything. I only have to try values from here to here. Well, what value should I try? Well, in reality, it could be anything, but it wants you to try the rational ones. So let's do the rational ones. So 120 over here, 1 over here. So 120 and 1, 60 and 2, 30 and 4. Oh, I missed one. 40 and 3. 30 and 4. 5, and we've got all sorts of ones here. Okay, 5 and I guess that would be 24. 6 and 20. 10 and 12. I'm missing a 15 here, aren't I? 120 divided by 15. All right, yeah, 8 and 15. And that's it, okay? So which ones do we have to try? Well, only these guys, because we've kind of squeezed ourselves in here. We don't have to try 15 because we already tried it. I'm going to cheat here. I'm pretty sure it's one of these guys, 2, 3, or 4. So theoretically, you would like guess and check here. I'd use Desmos. Let's see. Let's try 4. 1, negative 15, 74, negative 120. So we get 1, 4, negative 11, negative 44. This is 30, negative 120, or sorry, positive 120. So this is 0. Sorry, you didn't see all that. Now, here's the good news. We found one of our roots. And on a cubic, once you found one of your roots, this is happy times because what's left over is quadratic. So basically what I've gotten here is x minus 4, and then we've got x squared minus 11x plus 30. Well, quadratics we know how to deal with. We don't have to do any fancy stuff. Here I can go, okay, this is x minus 5, x minus 6. So our solutions wind up being 4, 5, and 6. Or sometimes this is going to be something that's gross that we have to do quadratic stuff on. So that was the first example. Let me do one more. All right, let's look at this guy here. So we want to establish upper bounds and lower bounds. Now, these are all positive. That's no sign changes. So what's going to be our positive bound, or our bound on the positive side? Well, it's going to be 1. Because I know I'm not going to have any positive integer solutions, or any positive solutions at all. On the negative side, okay, we have 3 sign changes, so it could be 3 or 1. So I am going to have to look on the negative side. So let's check it out. Let's try out, I'm guessing in the dark here, 1, 3, 9, 27. So 1, negative 3. Now 0 is okay, all right? 0 counts as a sign change. We get 0, 9, so positive, negative, positive. Did I guess well here? All right, so it appears this is a lower bound. Okay, so our upper bound is 1, our lower bound is negative 3. If I went negative 2, I don't think this would work. I don't think we can go any lower than that. See, we don't have a sign change here. So since there's no sign change, negative 2 won't work. So my solutions have to be between negative 3 and 1. And we accidentally found that negative 3 is 1. I don't think I made that real clear. Let me put this back up real quick. 1, negative 3, 0, 0, 9, negative 27. Okay, so this is one of our solutions, one of our roots. Well, what's left over? Well, it's this right here. It's x squared plus 9. Well, I could look for more roots just by guessing and checking here, or I could say, okay, this is a quadratic. I should be able to solve this. Square root both sides. X equals plus or minus 3i. So our 3 solutions wind up being negative 3, positive 3i, and negative 3i. But once you've got one root, you can take it out and reduce it down to a quadratic, which is something that we know how to deal with. All right, so again, I have no problem at all if you use Desmos to find your rational roots, and then you can use quadratic formula or whatever you need to do to find any irrational roots if you have them. Okay, but these are some techniques that you can use to kind of understand a polynomial without having to use a calculator. But there you go.